Okay, so when we talk about domain and range, we're talking about making these lists in order, and it depends on which number line we're focused on. So if we're talking about the domain is the x-axis, and the range is the y-axis. So I'll put that in red, y-axis. So the big thing about domain is domain is from left to right. So if I want to make a list of the domain from left to right, keeping in mind that the x-axis domain is set up like this, where if you go far left, it's negative infinity, far right is positive infinity. So if you look at the graph, if you look at the left end has an arrow which indicates it's going left forever. So that means we have a domain starting from negative infinity. We look at the right end has an arrow, so that indicates that it goes to the right forever, so that heads towards positive infinity. So remember again, these are all based off of the x-axis only. Get rid of this stuff. So then the y-axis is set up so positive infinity is pointed up and negative infinity is pointed down. So if we're talking about the range, and we want to find the range of this graph, the range, if I start from the bottom of the graph has an arrow pointing down, so this goes down forever, so that's negative infinity. And then the top of the graph has an arrow which indicates it's going up forever, so that's also positive infinity. So this graph goes in all directions, left, right, up, and down forever. So that's indicated by negative infinity to positive infinity, and you can also call that all real numbers. So in this set of notes, there's actually a lot of information in here, and I'm going to try to give you the information from like easiest to the part that's most challenging. So these are all the definitions we have to know. So I'm going to start off one by one, and I'll flip back and forth and talk about some of the things that I think are the easiest ones to find. Actually, they're kind of in order from what I think is easiest to the things that students struggle with the most. So starting with roots, the root, you're going to have to get familiar with this name. The root is the point on the x-axis. So it's basically like the x-intercept. So you have to know different names for it because they use these names interchangeably. They might say in one problem find the roots. They might say find the zero, find the solution, or just flat out find the x-intercepts. But the root is the point on the x-axis. So if we go through all of our graphs, we can go label all the roots and zeros, x-intercepts, solutions. So again, zeros. So that's the word they're using this time. If we go look at the graph, our zeros are located on the x-axis. So if that's 2, 4, that's negative 6, 0. And then there's a second one right here on the x-axis, and that's at 1, 0. So we'll go and do it for all the graphs. So x-intercepts, there it is right there. That's at 0, 0. This one has 2. It's got one here and one here, so it looks like it's at negative 3, 0, and then 1, 0. If I go to the next page, this one looks like it also has 2. There's one at negative 3, 0, and then the other one is at 1, 0. And guys, the reason why it's called zeros is because the second number is always 0. So that's why they call them zeros. Okay, we're going to go back to the definitions. Let's go to the next definition. So the definition of maximum, so we're here now, it's going to be the highest point. Now, when you look at a max, the picture looks like a speed bump. So it goes up like this, and then the point at the very top would be the maximum. So we're going to go through all of our graphs, and we're going to try to find the maximum. Keep in mind, if there's more than one of those little speed bumps, the high point, you can have more than one maximum. If you don't have that part of the picture, if it doesn't have that bump, then it doesn't have a maximum. So in those cases, we would just say it does not exist. So we'll go jump down to the maximum right here. The maximum would be this spot right here. So we just list the coordinates. So it's at negative 3, and then it's up to 9. That's the only maximum that graph has. This graph does not have a maximum because it doesn't have a bump where it goes up and back down. So there is no maximum. So this we say does not exist. And we just put D in. The next graph definitely has a maximum. It's got this high point right here. So that's at negative 1, and positive 4. If I look at the next graph, this one definitely has a maximum, so that's the maximum. That's at negative 1, 16. If I go down, that's it. That's it for maximum. So we go back over here to talk about minimums, if you know a maximum, then you should be able to find the minimum, because the minimum is just the lowest point. So the lowest point is exactly the opposite. It goes this way. So it would be this point right here. The way I think of a minimum is if you can pour water into it, and the water stays in there, then you have a minimum. So we would have like water in here. So if we go find all of our minimums, this graph right here has a minimum, because the water would stay in that spot right there, so that would be at 1, 0. Let's see, we've got no minimum on this one, because we don't have a shape like this. So there's no minimum, so this does not exist. The next one also does not have a minimum, because we don't have this shape going on. So that does not exist. And then this one actually has two minimums. So you have one here and one here. Both those spots can hold water. So we have a minimum at -3, 0, or yeah, it's -3, 0, and also one at 1, 0. So that's it for minimum. Now we're going to go back, go down the list. I don't see it on the list because we've already talked about it. So I'm going to talk about domain and range one more time. We'll go find all of the domain and ranges for our graphs. Domain is left to right. Range is bottom to top. So if we look at this graph, x is this way, -infinity to +infinity. So this graph goes left forever, and it also goes right forever because it has the arrows on the left end and the right end. So your domain is -infinity to infinity. The range, same thing. It's going down forever, it's going up forever. So that's -infinity to infinity. The next graph, it does not go left forever. This is how far it goes. It goes to this spot right here. 1, 2, 3, 4 to the left, so it's -4 with a bracket because of the black dot. And then it goes to the right forever, so it goes to +infinity. For the range, the lowest point it goes on the x-axis is this spot. So it's at -2. We have -2 where it starts. Got bracket because it's black dot. And this graph actually does go forever even though it slows down. So it goes up to +infinity. This graph, let's see, domain, left side, arrow, right side, arrow. So that means -infinity to infinity. So this graph never goes straight down, it goes outward forever. The range, bottom to top. So the bottom has arrows, so that means we have -infinity. The top is this height, so that means it goes up to 4, and that's a black dot. So the next graph, let's get rid of this stuff. Left side, arrow, right side, arrow, so that's -infinity to infinity. And then we have range. Range is from bottom, so bottom is here. So it's a tie, there's two of them, but that's just 0. So it goes from 0, and how high does it go? It does not stop here, it goes past it. So at the top, it's got these arrows, so that means it goes to infinity. Okay, so back to these definitions. The next thing we're going to talk about is the end behavior. And it's exactly what it sounds like. It says end behavior. What we want to know is which way are the ends headed? Are they headed up or are they headed down? Now before we can answer that question, we have to know how to read the directions. So this says as x approaches -infinity, that just means the left side. So look at the left end and see which way the y's are going. Are the y's going up or are they going down? If they go up, it's +infinity, and if they go down, it's -infinity. Now, all of these end behaviors, they're going to have two ends. They're going to have the left end and the right end. So this right here, since it says +infinity, that's going to be the right side. So right side. And f of x just means y. So as we look at the right end, the y's head towards blank. So if it's up, it's +infinity. If it's down, it's -infinity. So let's go do all the end behaviors for these graphs. So end behavior, we have left end, -infinity, x negative. So if x is negative, left end heads down. If it's down, that's -infinity. If you look at the right end, so this is right end right here, +infinity. The right end is headed up, so that's +infinity. Get rid of this stuff. Now this one is kind of strange. So if you look at the end behavior on the left side, it actually does not go to -infinity because it actually stops right here on the x-axis at -4. So So we can make this adjustment just by putting a -4 right here instead. So where does the graph head when it goes to -4? Where do the y values go? The y values head to -2. That's the only time the answer is going to be a negative. A number, not a negative, a number. So again, if this was to just stay negative infinity, we couldn't answer it because the graph doesn't go to negative infinity, so we would just say does not exist. But I want it to exist, so that's why I changed it to a 4. Now your test and your worksheets, they should have the 4 or the number already. The right end. The right end has an arrow, so that's headed up. That's infinity. Okay, left end, down. Down is negative infinity. Right end, also down, positive infinity. Clear all this stuff out. So if I say, let's see, left end, left side is up. So that's positive infinity. Right side is also up, positive infinity. So that's it for increase and decrease. So now next, so we got this one covered, and behavior. Actually, next one is increase and decrease. So the increase and decrease, the hard part people kind of get mixed up on is it's all about x values. And it's the interval notation of the x values where the graph is going up. And we also, we never use brackets on these answers. So if we were to go to a graph and talk about increasing versus decreasing, you can tell, like, graphs, when you read them from left to right. So this part right here is going up. This next piece is going down, all the way to here, and then it goes up again. So what we do is we just mark it off on the x-axis where they change directions. So right here, it's changing directions. It goes from blue to red. So that means this number is important. That's -3. Then it goes from red to blue. That's changing directions again. So that's at +1. So then we also have the infinities marked off. So you basically have your increasing and decreasing intervals. So the blue part is increase, the red part is decrease, and then the blue part is increase. So if we want to list the interval, the increasing interval is from -infinity to -3. So it goes -infinity to -3. Then it starts increasing again at -1 into infinity. So we got -1 all the way to infinity. So it goes up twice. So that's why we have two answers. And you have your decreasing portion. The decreasing portion is from here to here. So from -3 to 1. And we never use brackets on those. So let's see, we got another one over here. This one right here, it's increasing. If you look, it's going up. It's going up forever. So where does it start increasing? It starts increasing from -4 until forever. And does it decrease? It does not exist. It never decreases. It's always going up. Okay? Increase versus decrease. So increase is going up. So this is up. Actually, I'll use blue so you can see those colors again. So this is the up side. That's my increasing side. And then my decreasing side is from here down. So what we really care about is where they change directions, because that number has to be used in the interval. So we have -infinity over here and +infinity right here. So these, I don't know if you guys can see this, but if you look at the axis from here to here, that's the interval, -infinity to -1. So we're going to put that for the increasing part, -infinity to -1, and that's why I like drawing all over the x-axis like that. So then if you look at the next one, let's see, I'll change colors. We'll go into a purple, maybe purple right here. So the increasing part was the yellow part, and the decreasing part starts here and goes this way forever, since the graph goes forever. So it's again from -1 to infinity for the decreasing part. -1 to infinity. So this one's got a few parts to it. So left to right, this is going down, and it's going up, then it's going down, and it's going up. So the parts that we care about is where they change directions. So this number is significant. This number right here is significant, -1. This number right here is significant, +1. And then we have our positive infinity and our negative infinity over here. So increasing. Increasing is the first interval here. Increase. Well, actually, that's decrease, sorry. flip that back. So decrease is this interval, increase is this interval, decrease is this interval, and increase is this interval. So we have all the numbers on the x-axis, you just got to write it down. Increasing is first, so negative 3 to negative 1. And then we have another one from 1 to infinity. The decreasing is from negative infinity to negative 3. And then again from negative 1 to 1. So let's see what else we got here. The average rate of change. The average rate of change is the slope. So you guys should know the slope as the rise over the run. Or you might know it as y2 minus y1 over x2 minus x1. So some of these graphs may ask you for an average rate of change. Actually, these graphs that I have, they don't say that. But a question that they might say is, what is the average rate of change from the max to the min? So we could actually just use the points from the maximum and the minimum to count over the rise over the run. Or you can write down the coordinates and just plug them into the formula. So the coordinates are, I think that's negative 3 and up 9. And then this one is 1, 0. So using the y2 minus y1 formula, I would have 9 take away 0 and negative 3 take away 1. There it is. Hey, I'm just recording a video for my class. You walked in perfect time.